Number 2 says, given the vertices, determine the quadrilateral's most specific classification. So we have QRST. So just to give us a visual of what we need to do, not drawn a scale of course, we have QRST. So we need to be able to identify what we have. So we can either have a parallelogram, we could have a rectangle, rhombus, or a square. Alright, so we do have to use the distance formula. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared. So first we need to find the distance between QR. Q is at -2, -7, and R is at, let me not even write that, is at 1, -5. We're going to use the distance formula after we do our subscripts. Subscripts, of course, mean order. So that's our first x, first y, x2, y2. D is equal to, right here, D is equal to the square root of, that's a 1, so we have 1 plus 2 squared plus -5 plus 7 squared. So 1 plus 2, 3, so we have 3 squared. -5 plus 2 is plus 2 squared. So 9 plus 4 is 13, so we have square root 13. That's our first answer. Now we're going to do RS. R is at 1, -5, and S is at 4, -7. x1, y1, x2, y2. It's important that we keep order when doing the distance formula because our answer would be incorrect. So we have 4 minus 1 squared plus -7 plus 5 squared. 4 minus 1 would be 3 squared, and then -7 plus 5 would be plus -2 squared. 3 squared, 4 squared would give us square root 13. Now we're looking at ST. S is at 4, -7, and T is at 1, -9. D is equal to the square root x1, y1, x2, y2. So D is equal to 1 minus 4 squared plus -9 plus 7 squared, which is equal to the square root of -1, or 1 minus 4 will be -3 squared plus -9 plus 7 will be -2 squared. So 9 times 9, or 3 times 3 is 9, 4 would give us square root 13. One more, we definitely have a parallelogram. So now we have TQ we're looking at. T is at 1, -9, and Q is at -2, -7, x1, y1, x2, y2. So D is equal to the square root of -2 minus 1 squared plus -7 plus 9 squared, which is equal to the square root of -3 squared plus 2 squared, which would be equal to 9 plus 4 square root 13. As you can notice, 4 sides are equal, so our only type of answer here would be the following. We could only have a rhombus or a square. Those are the only two types of parallelograms we could have here. So first we need to know that a rhombus, the diagonals are not equal, but for a square, the diagonals are equal. Alright, so let me move this up just a little. We're going to make this into 2 sections, and we'll keep this up just to see what our coordinates are. Our diagonals here would be QS and RT. So we have QS, and then we have RT. Q is at -2, -7, and then S is at 4, -7. R is at 1, -5, and T is at 1, -9. Now that we have our point, I'm going to move this all up. Okay, so what we're going to do here is we first need to label our subscripts, x1, y1, x2, y2, x1, y1, x2, y2, and we're just going to see what our diagonal is going to be. If they're not equal, we got ourselves a rhombus. If they are equal, we got ourselves a square. D is equal to the square root of 4 plus 2 squared plus -7 plus 7 squared, which we got our square root of 6 squared. -7 plus 7 would give us a 0, so we have right here square root of 36, which would be equal to 6. Alright, so we have 6 right here, and let's see if RT would give us the same solution. D is equal to the square root of -9, or -1, oops, -1 minus 1 squared plus -9 plus 5 squared, which is equal to the square root of -1 minus 1 would be -2 squared plus -9 plus 5 would give us a -4 squared, which is equal to 4 times 4 would, or 2 times 2 is 4, so 4 plus 16 would give us square root 20. As you can see here, these are two different answers because 2 times 2 is 4 and 4 times 4 is 16. They're not the same, therefore we have ourselves a rhombus. Alright, and that is our number 2 from the homework.